Hello again. Okay, we're going to do the cube root parent function now. And so you can see here y equals the cube root of x. This is my cube root parent function. And as you can see, I've picked some values that I know are going to work nicely. I'm not picking -2, -1, 0, 1, and 2 anymore. I'm using numbers that are going to work out when I take the cube root of them. So when I take the cube root of -8, as we remember, that gives me -2. -1 gives me -1, 0, 1, and 2. So I'm going to go ahead and plot those points. And as you can see here, this makes a sideways cubic. Okay, just like a square root made a sideways parabola, the cube root makes a sideways cubic. So it literally looks like x cubed and you just turned it on its side. So when it comes to graphing cube root functions, you have to have a total of 5 points. Right here in the middle, this is what I call the cluster. And then you also have 2 tail points. Okay, a total of 5 points when you're graphing a cube root function. You have to have the cluster, and then you have to have the 2 tails. Now from here, let's talk about the domain and range. For my domain, did I have any restrictions on my x values? Did I use negatives? Did I use zeros? Did I use positives all in the same fashion? I did. So the domain here is all real numbers. And likely so, the range was all over that y-axis, so the range here is also all real numbers. Cube roots are easy in that fashion. Their domain and range is always going to be all real numbers. So just like before, all of our transformations are the exact same. Okay, they have not changed whatsoever. So let's talk about our transformations. We first have a stretch by 2. We went left 1 and down 4. Okay. Now, domain and range, as we mentioned, it is all real numbers, all real numbers. Now, a really important question, very important question. Where is the h and k coming into play? So with a square root, we saw that h and k was our starting point. However, with a cube root, that h and k is your center cluster point. Okay? The h and k here is the center cluster point. All right? So from here, you're like, Money, how in the world am I going to graph these points? Okay? It's all right. We're going to deal with this one step at a time. So here, our center cluster point, I'm going to come over here. Our center cluster point was at -1, -4. Okay. So, when I plug in -1 for x, what happens underneath here? That goes to 0. Well, we can take the cube root of 0. That's just 0. Okay? So just like we did with square roots, we want to pick numbers that when we plug in, they work out nicely in our favor because we're taking the cube root. All right? So from here, let's figure out what are some nice values for x that we could plug in. Well, what can I do to make the cube root of x plus 1 be a nice number? Well, what can I take the cube root of? Well, I can take the cube root of 1, right? So what would I have to plug in order to make that work? I would want to plug in a 0. 2 times the cube root of 0 plus 1 gives me 1, and then minus 4. So that gives me 2 times 1 minus 4 gives me negative 2. So I'm going to plot the point 0, negative 2. What would be another good value that we could plug in? Let's think. Can we make the inside go to negative 1? Yeah, we can make the inside go to negative 1. How could that happen? I would have to plug in a negative 2. So I'm going to add negative 2 to my list. Okay. So that would give me 2 times the cube root of negative 1 minus 4. Well, that gives me negative 2 minus 4, which gives me a total of negative 6. So I'm going to plot the point negative 2, negative 6. And as you can see right there, I have my cluster. Okay. Well, I need my 2 tail points. How do you get your 2 tail points? Well, you make the inside go to 8 and negative 8. That's how you do it. Okay? You make the inside go to 8 and negative 8. So let's think. If I want the inside to go to negative 8, I would have to plug in negative 9 in order to make that happen. So 2 times the cube root of negative 8 and then minus 4, that gives me 2 times negative 2 minus 4, which gives me negative 8. So if I plug in negative 9, I get out negative 8. Okay, to get my other tail, I need to make the inside go to positive 8. Well, how do I make the inside go to positive 8? I make that a 7. So 2 times the cube root of 8 minus 4, that gives me 2 times 2 minus 4, which gives me 0. So if I plug in 7, I should get out 0. From here, I have a total of 5 points. Now I'm able to graph. Okay. So again, let me reiterate, if you're having trouble figuring out what numbers to plug in for x, you want to make underneath the radical be a perfect cube. So that means make it 1, make it negative 1, make it 8, make it negative 8. If you are having trouble with this, please come see me, come ask me a question, come talk to me. You can use a calculator to help plug in if you need to. But other than that, that's pretty much the hardest part, is figuring out what to plug in and what does it simplify to. Let's do another one. This one's a little different, okay? This one, you'll notice that it's not written in the right form, so we need to fix that. We need to say this is y equals negative 1/2 times the cube root of x minus 2, and then you have that plus 3 on the back end. They just tried to confuse us and write it not in regular form, like transformation form, but we saw what they were doing. We got them. Okay. Transformations, we can list all of them here. You have a reflection over the x-axis, and we're going to see how that affects the graph here on this one. You also have a compression by 1/2. You went right 2 and up 3. Domain and range, that never changes for these cube root functions. They are both all real numbers. All right, so I'm going to come over here and I'm going to make my list of values. And remember that H and K, that's the middle cluster point. So your middle cluster point is going to be at 2, 3. Okay. From here, again, we want to set that underneath the radical equal to 1 or -1, 8 and -8. So I'm going to start by making it 1 because I like to do my cluster first, but it doesn't matter, okay? Does not matter. So from here, what value is going to make underneath the radical become a +1? It would make a 3, it will take a 3 to make that go to +1. Okay? So from here, you have -1/2 times the cube root of 1 plus 3. That gives me -1/2 plus 3. That gives me 2.5. So I'm going to come over here at 3. I'm going to go up 2.5. Same thing on the other side. If I want to make that go to -1, what am I going to have to plug in to make that go to -1? I'm going to have to plug in a 1. So -1/2 times the cube root of -1 plus 3. That gives me +1/2, because a negative times a negative gives me a positive, plus 3. So when I plug in 1, I get out 3.5. So when I plug in 1, 2, 3.5, there we go. I got my cluster. How do we get the 2 tail points? We make underneath that radical go to 8 and -8. So let's do 8 first. Does it matter? No. Okay. What's going to make underneath here go to 8? 10. 10 minus 2 is going to make that go to 8. So I have -1/2 times the cube root of 8 plus 3. Well, the cube root of 8 is 2, so -1/2 times 2 and then plus 3. -1/2 times 2 gives me -1 plus 3. That gives me 2. So when I plug in 10, I get out 2. I'm going to plot that point right there. I'm going to do the same thing, except now what's going to make this go to -8 under here? That would be -6. So then I have 1/2 times the cube root of -8 and then plus 3. Well, that's -1/2 times -2 and then plus 3. So that gives me 1 plus 3, which gives me 4. So when I plug in -6, I get out 4. So here we go. 1, 2, 3, 6, 1, 2. I have all of my points. I'm ready to graph. Like I said, guys, the hardest part is going to be how do you figure out what your x values are. But again, as long as you focus on what's going to make underneath that radical go to 1, -1, 8, and -8, you will be good to go on getting those values. If you're having trouble with this, rewatch the last 2 videos. Okay, that will really help. And as you can see here, that reflection over the x-axis, it just made us look like a decreasing function was all. I forgot to mention that earlier. Sorry. All right. On this problem, it says, how can you rewrite the function so you can graph it using your transformations? So You'll notice here on this problem, the x isn't by itself. It has a 9 sitting in front of it. But what we can do is we can rewrite this by factoring that 9 out. Now, from here, you're dealing with a square root function. So what's the square root of 9? You can rewrite that and say, well, that's 3, and I'm left with the square root of x plus 2. Now, you can see very easily you have a transformation of a stretch by 3, and then you went to the left 2. So be extra careful here, guys. This is a square root function. So is your domain and range all real numbers? No. Your domain goes back to those restrictions. X has to be greater than or equal to -2. We don't have a k value, so we're going to say y is greater than or equal to 0. So since this is square root, I got to think back to that last video. So you're going to plot the point -2, 0. That's my starting point, -2, 0. And we need a couple more points to graph this. So what would be a good point to plug into our equation here? Could we plug in a -1? Yeah, because that would give me the square root of 1 times 3, which is 3. So -1, 1, 2, 3. Could we plug in a 2 as well? I think that would work. 2 plus 2 gives me 4. The square root of 4 is 2. That would give me out 6. And I think that's enough points. So as long as you show your graph, you're good to go. So just because there's a number underneath the radical hanging out in front of that x, it's all right because we noticed how we can handle that. We can factor that 9 out, and the square root of 9 was 3. We're going to do the same thing on this last problem here. We're back to dealing with cube roots. But as you can see, there's a number hanging out in front of that x, and we can handle it because I can rewrite this as the cube root of 8 times x plus 4. We have a GCF of 8 that we can factor out. And now you have the cube root of 8. So you can rewrite your function as 2 times the cube root of x plus 4. So your transformation, you would say stretch by 2. Ooh, I completely forgot that there was a -2 on the back end there. So we got a stretch by 2, left 4, and down 2. Domain and range for a cube root is always all real numbers. And I'm going to go ahead and start my table of values. My center cluster point would be at -4, -2. And again, from here, let's look at our equation and see what would be some good values here. Well, again, I want this inside to go to 1. So what would make that go to 1? A -3. So when I plug in -3, I get out 0. Now what would make this underneath here go to -1? That would be -5. That would give me -4 as my output. And you can see I have my cluster. Now all I need to do is finish up with the tails. What's going to make this go to -8? that would be negative 12. So when I plug in negative 12, I get the cube root of negative 8, which is negative 2. Negative 2 times 2 gives me negative 4 minus 2 gives me negative 6. Going off the graph here. All right. And what would make this be a positive 8 if I plugged in 4? 2 times 2 gives me 4, minus 2 gives me 2. I have all of my points, and I can graph. All right. That finishes up graphing radicals. On Canvas, I've posted some mini quizzes since I know we didn't get to quiz over the second half of this module. So on Canvas, there's a 6.5, a 6.6, 6.7, and a 6.8 mini quiz. And you get 2 attempts, and your highest score is what's going to go in the grade book. So you have 2 chances. If you want to give those a shot, I would be more than happy to help your grade out, boost it up a little bit before we go into fall break. If you have any questions or any concerns or comments or anything, please feel free to come and talk to me at any point. If you need anything else, just let me know.